we have that x is equal to 2 as a root, okay, which implies that x minus 2 is a factor. So now what we could do is we could divide that into here. So we have x minus 2 divided into x squared minus 6x plus 8. So obviously, when it comes to the quadratics, you just list out all the possible factors, and you just maybe do grouping on it. But while I'm taking this particular approach with the division, I might as well do the division on this. So x into x squared goes x times x gives us x squared. X times minus 2 gives us minus 2x. We subtract this from this, which goes minus plus, that cancels, which gives us now minus 4x plus 8. The minus 6x plus 2x gives us minus 4x. And we have this piece here that we haven't done the division on. X into minus 4x goes minus 4 times. Minus 4 times x gives us minus 4x. Minus 4 times minus 2 gives us plus 8. And when we multiply across by minus 1, that becomes plus, that becomes minus. And you see that they cancel to give us 0. So there you go. What we now know is that this divides into this amount of times, which basically means that x minus 2 times x minus 4 is actually equal to x squared minus 6x plus 8, which has to be equal to 0. Okay? Well, what does that mean? That means that x minus 2 must be equal to 0, or x minus 4 is equal to 0, which gives us x is equal to 2. X is equal to 2, which we started with up here, or x is equal to x is equal to 4. Okay. So now we found all of our factors using the rational root test. It's quite long-winded. Okay, we probably should have really just, the rational root test is helping us to split this up, this minus 6x, by grouping. You see that we could do this by grouping here, yeah? Is, let's say, by grouping, consider an x squared minus 6x plus 8. Okay, so you've probably done it this way. Okay, so let's factor let's factor x squared minus 6x plus 8 equals 0. Okay, so you probably took the coefficient 1, multiplied it by the 8, that gives you 8, and listed all the factors. Okay, well, it's 1 times 8, it's minus 1 times minus 8, it's 2 times 4, it's minus 2 times minus 4. Okay, and am I missing something? No, I'm not missing anything. And they're all the possible values, all the possible factors. And then what we do is we look down this list to see which two add together to give us the minus 6. And it's actually these two here. So from a grouping perspective now, this becomes x squared minus 6x plus 8 is equal to 0, which implies that x squared minus 2x minus 4x plus 8 is equal to 0. Splitting the minus 6x up into two terms based off the factorization of the 8. And now grouping. Okay, we group these and we group these. What's common here is an x. X times x gives us x squared. X times minus 2 gives us minus 2x. What's common here is a minus 4. Minus 4 times x gives, see, we want to make sure that what we're left with is the same in here. So minus 4 times x will give us minus 4x, which is an x that we require. Minus 4 times what gives us plus 8? Well, minus 4 times minus 2. And once again, you can see that we have a common factor here and here. Let's heist that out. So that implies that x minus 2 times, well, when you take it away here, you're left with an x. When you take it away here, you're left with a minus 4 is equal to 0, which implies that x minus 2 is equal to 0, or x minus 4 is equal to 0, which implies that x is equal to 2 or x is equal to 4. So either way, okay, what we've done is we found the roots of this particular polynomial. Okay, the first root that we found was x is equal to minus 1. The first root was when x is equal to minus 1, and then when we continued on, we found two more possible roots. We had x is equal to 2, and then when we divided that in, we ended up with x is equal to 4. So in this particular case here, the roots of, or the solutions, that's what we should really say, the solutions, or the roots of the polynomial, where's the polynomial gone, of x cubed minus 5x squared plus 2x plus 8 equals 0 are minus 1, 2, and 4. Okay. So I've seen things like, let's say, questions like, let's say the set A equal to the set of x's such that x is an element of, let's say, the integers. Right? The integers will do here. We could have the rationals, yeah, and we have that x cubed minus 5x squared plus 2x plus 8 has to be equal to 0. And what we need to do is we need to find the x's that are in this set that satisfy these two conditions. This is our set builder notation. And what I've just shown is that we've just found these two things. So therefore what we have is we have A is equal to the set that contains minus 1, 2, and 4. Okay. Okay, guys, once again, this is Jonathan Lambert with Maths and Stats. And I hope that this video, another video in a series of videos dealing with polynomial functions, solving cubic equations using the rational root test. I hope that this video was intuitive, and more importantly, I hope that was helpful for you. And thanks for watching. Okay, bye-bye.